In this video, I will be onboarding a LoRaWAN end device to the Senet Developer Portal. The Developer Portal is a free service that can be used to become familiar with LoRaWAN connectivity, as well as what Senet has to offer. It is a device-centric management portal, whereas Senet's commercial network is fleet-based. With that said, because it is device-centric, a user can onboard up to 10 devices and 2 gateways. This video assumes that you have Senet public network coverage. If you do not have public network coverage, you will also need to onboard a LoRaWAN gateway. For instructions on how to do that, we have another video in this series that will walk you through the process. Prior to onboarding the device, if you have not already done so, please create a new account at portal.senetco.io. Just click Create New Account. Now that you have created your account, you can log in. You'll note, because this is a new account, there are no gateways or devices onboarded. The device I am working with today is a Milesight AM107. It is an ambient air quality sensor that monitors temperature, humidity, CO2, TVOCs, light, and motion. It is very user-friendly and easily configurable. Now let's begin the registration process. Click on the plus button and select Register Device. This new window will appear. The first item we'll have to enter is the device EUI. This is an enterprise unique identifier, which is an 8-byte hex value. Each LoRaWAN device has one, and as the name describes, it is unique for every device. If you want additional information about device EUIs, please check out our FAQ by following this link. If for some reason your device does not have a device EUI, you can allocate one from Senet's EUI registry by following this link. If this is the case, you will then need to follow the device manufacturer's instructions to configure your device with the Senet-generated device EUI. The Milesight AM107 identifies the device EUI on the back label. Let's enter that device EUI. The next step is to choose the activation type. In the developer portal, you can use OTAA. OTAA stands for Over-the-Air Activation. This is the default setting for many devices. This allows the device to join and negotiate its keys with the network server. The other method is ABP, Activation by Personalization. In this case, the device keys are filled in on registration. ABP is reserved for specific use cases on Senet's production network. OTAA is a far more secure method. OTAA end devices are provisioned with root keys, and then when activated, the end device performs a join procedure with the Senet network. The root keys are utilized to derive session keys, providing end-to-end security for the device communication. In this exercise, we will be using OTAA, and as such, the Milesight AM107 comes with its own manufactured device information. So I'm going to select User Specified Join Information. I'll just quickly edit this description and select a device type. In the case of the AM107, the device type is not listed in the drop-down menu. We will have to enter it manually in a similar convention as the other devices in the list. Now let's select Configure Keys. There are multiple ways in which a device manufacturer provide the user-specified join information, which is the join EUI and the application key. Some devices will have the join EUI and the application key directly on the label or in a QR code on the device. Others will provide documentation that is shipped with the device or a soft copy via email. In the case of the AM107, it is actually located in their user guide. As you can see here, there is an app EUI defined as well as the application key. Some devices still call the join EUI the app EUI. In that case, the join EUI and the app EUI are identical, which is the case for this particular device. Let's enter the join EUI and the application keys and select Register New Device. At this point, our device is ready to join. Let's take a look at the portal again. On the left-hand side, you'll see that for this particular device, so far it says there's been no contact for join and there's no contact for last heard. That's because this device has not joined the network yet. Let's power on the device to initiate the join process. Now that the device has joined the network, let's take a closer look by selecting the device UI that is listed. We will be brought to a list of device transactions that have occurred for this device. As you can see, the device sent a join request, and the network server responded with a join accept. It established a new security session, and the device began transmitting uplinks. You'll see that the network also allocated a dev adder for this device. Behind the scenes, the network has generated our network session key, which was derived from the application key that we provided when we registered the device. A few notable pieces of information here. You can see that the device is communicating on a variety of channels. The data rate is currently data rate 0. The device has been configured for a 10-second transmit interval for this test environment. The uplink transmit interval is a configurable value. The 10-second interval is a very rapid interval for LoRaWAN. Typical LoRaWAN devices transmit much less frequently. You will often see devices transmitting as little as once per day, or sometimes as frequently as once per hour. You can see that the payload that is being passed up is unencrypted. This is by design in order to aid developers. For production customers, all data is encrypted in the user interface. If the data were encrypted, a lock would precede the data. In closing, that's all you need to get a device registered and transmitting uplinks on the Senet network. For more information regarding the developer account, please go to docs.senetcode.io and select Developer. Continue on with this video series to learn how to forward data to an application enablement platform, or register a gateway, or learn more about our production environment.